Okay. Now for this one, it's really kind of a throwback to the first example we had, because we know our x comma y is just 3 over 8 and our y. Okay. So we know our x is equal to cosine of theta. So we have that already. All we have to do is find our sine of theta. Okay. So we can do that just using our x squared plus y squared equals 1. And I'll put that underneath it. So x squared plus y squared equals 1. And we know we can use that because they already told us it's a unit circle. Okay. So that's 3 over 8 squared plus y squared equals 1. And you can solve it here, or you can move it over and solve it. Completely up to you. So if you made that 9 over 64 squared, well, 9 over 64, not squared, plus y squared equals 1. If we subtract 9 over 64 from both sides, y squared equals 1 minus 9 over 64. Okay. So that 1, since we need a common denominator, we make that y squared equals 64 over 64 minus 9 over 64. I'll move that up a little bit. Okay, so we can just go ahead and continue that up here. So that means that y squared is equal to 55 over 64. Okay. So if we square root both sides, we can solve for our y. Okay. So if we square root both sides, we have y equals either positive or negative square root of 55 over square root of 64, which is just positive or negative square root of 55 over 8. Okay. Now we know, since it's in quadrant 1, that x and y are both positive in quadrant 1. So we're going to pick the positive one. Okay. Remember, whenever they tell you the quadrant, it's for a reason. Okay. So we know that y is equal to square root of 55 over 8. Okay. So we already know, just from the very beginning, that our cosine of theta, sine of theta, is equal to, remember, that's just your x comma y, which is equal to 3 over 8. And our sine of theta, which is our y, square root of 55 over 8. All right, any questions on that one? All right, I'll leave that up there for a few. Mark that just in case. All right, so now we already know about the points on the x-axis and y-axis. Now we're going to look at certain values in between there. again, let's draw. That was pretty good. Probably won't be able to draw another circle that nice all day. Okay, so we have 1, 0. We have 0, 1. Okay, we know those points. Okay, so now what we're going to do is we're going to find the points where theta is equal to, say, 30 degrees, which is pi over 6. Actually, I'll draw it out here on the outside, so it's not a whole lot of. Okay, so theta equals 30 degrees, just pi over 6 radians. You don't have to write the radians. Whenever you have a pi in there, you automatically assume it's radians. So it's going to be either radians or degrees. So the radians is just writing the RAD is kind of unnecessary, but it's not too bad to practice it. Okay, so let's say here we have 45 degrees, or pi over 4 radians. Okay. Say here, we go up a little more, where our theta is equal to 60 degrees, which is pi over 3 radians. And we know here, if we swing it all the way up to the top, theta equals pi over 2 radians, or 90 degrees. Okay, so for right now, we're just going to worry about those only because we can kind of fill in the rest later, because all the other quadrants are somewhat mirror images of that first quadrant. So, okay. So I'm going to show you a trick on how to, because you're going to have to remember all of these, so the trick actually comes in handy. Okay, so here we have our theta. Here we have our x, which is our cosine of theta. We have our y, which is our sine of theta. And we get exactly what that terminal point is. Okay. So terminal point is really just a fancy way of saying if we swing theta so far, where will we end up on the circle? That's our terminal point. Okay, so we're going to start at 0 for our degrees. Then we're going to have 30 degrees, or pi over 6. Okay, we're going to have 45 degrees, which is pi over 4 radians. We're going to have 60 degrees, which is pi over 3 radians. And we're going to have 90 degrees, which is pi over 2. We'll bring that up a little bit. Okay, so all of these are going to be over 2. Okay, so starting with our x, the pattern you can look at is this is square root of 4 over 2. Square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2 for your x's. Okay. So this actually simplifies to 2 over 2, which is 1. This is just square root of 3 over 2, so that stays the same. This is square root of 2 over 2, so that stays the same. Square root of 1 over 2 is just 1/2. And square root of 0 over 2 is just 0. Okay. So for each of our terminal points, we have our x values. We have 1, we have square root of 3 over 2, we have square root of 2 over 2, we have 1/2, and we have 0. Okay. So now for the y, we do the exact same thing, but we go in reverse. So this would be our square root of 4 over 2, square root of 3 over 2, our square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2. Okay, so that means this one would simplify to 0, 1/2, square root of 2 over 2 and square root of 3 over 2 stays the same. Square root of 4 over 2 is just 2 over 2, so that's just 1. So now we have our y values. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Okay. So now we have each one of those points on the unit circle. Okay, so if we just, I don't want to clutter everything up there. Not bad. So we have our x and we have our y. And remember, this is our 30 degrees here. So 30 degrees. Oh, we already know our 0. That's 1, 0. We already figured that out earlier. But at 30 degrees, we know our point is square root of 3 over 2, 1/2. Okay. At 45 degrees, which is a little bit higher, or you can write it as pi over 4, we know it's square root of 2, square root of 2. So square root of 2 over 2, square root of 2 over 2. Okay. So we know for 60 degrees, which is a little bit higher, we know it's 1/2 square root of 3 over 2. Let's clean that up a little bit. And we know right up here at 90 degrees, it's going to be 0, 1. Okay. So if you ever needed to know what the actual point on the unit circle is, that's how you can figure it out, just by that graph. So as long as you know how to count down and count up by 4, you should be able to figure it out. All right, any questions on that one? All right, I'll leave that up. And I think I'll do this one first. All right. Okay, so this one, I'm going to make the unit circle a little bit bigger. Move that over a little. Oh, move that down. There we go. And the reason I made it a little bit bigger is because now we're going to use these very points that we just figured out and show how we can now fill them out across the entire unit circle. Okay, so remember here, your 30 degrees or power over 6, square root of 3 over 2, 1/2. And that's our 1, 0. Then at 45 degrees, it's square root of 2 over square root of 2. Square root of 2 over 2, square root of 2 over 2. Then at 60 degrees, it's 1/2 square root of 3 over 2. And then we know here it's at 0, 1. Okay. So now we're going to figure out those 3 points, those 3 points, and those 3 points. And they are all different variations of those 3. Okay. So here we can see that just paying attention to the x-axis. I'll kind of highlight it a little bit because that's going to be the key to figuring out all the other points on the graph. Okay. So here we notice that we swung the theta up this way. Okay, so now what we're going to do is just keeping track of the x-axis. So we're now going to swing it up this way. Okay, which means we're still going to go square root of 3 over 2, 1/2. Oh, let me make that a little more room. And if we swung it up 45 degrees here, if we swung it up to 45 here, we'll be at the same square root of 2 over 2, square root of 2 over 2. Okay. So if we swung that up 60 degrees here, we'll right at 1/2 square root of 3 over 2. So I'm going to leave those there for now because we still have to tweak it a little bit. But for right now, we're just going to leave it. Okay. So let's say if we start here and we want to swing our theta that way. So if we swung it 30 degrees this way, again, we'll be at square root of 3 over 2, 1/2. If we swung it 45 degrees that way, we'll be at square root of 2 over 2, square root of 2 over 2. And again, if we started here and swung it 60 degrees that way, we'll be at that point, and we'll be at 1/2 square root of 3 over 2. And here's our 0, -1. Oh, well, let me move that over a little bit so I'm not in the way. There we go. Okay, so same thing here. Let's say if we decided to swing our theta that way. So if we did swing it 30 degrees that way, again, we'll be at square root of 3 over 2, 1/2. We swung it 45 degrees, we'll be at square root of 2 over 2, square root of 2 over 2. If we swung it 60 degrees that way, we'll be at 1/2 square root of 3 over 2. Okay. So you can see just swinging it back and forth across the x-axis is pretty much the same thing. The only difference, the only thing that makes those points different is whether or not it's positive or negative. Because remember, in this quadrant, x is negative and y is positive. So you're going to make all your x values negative. Other than that, they are exactly the same. Okay? And remember, in quadrant 3, I'll make that Q2 and Q3. Your x values are negative and your y values are negative. So you just make both of them negative. And, oh, we already got that one. Yep, oh, forgot Q1. Quadrant 1, everything's positive. So we don't have to worry about doing anything there. X and Y's are both positive. Now in quadrant 4, your X's are positive, but your Y's are negative. So you just make all your Y's negative. So X is positive, Y is negative. Nope, don't need a -0. Yep, and those are all of the special points on the unit circle. So like I said, once you figure out that first quadrant, which is really just what we did here, once you figure out those and you swing it going from the x-axis, you can kind of figure out the rest of them. All right, any questions on that one? All right. Okay. So really, you don't have to really know these. We're going to figure out a way to figure them out just using what we know in that first quadrant. So if they ask you what's this would be, let's say, I'll actually redraw. That'll be too much on that one. So you're going to be redrawing unit circles over and over. So like I said, it can get cluttered really fast. So, oh, anyone still writing? All right. Okay, so let's say close enough. That's our y, that's our x. Okay. So let's say if we have pi over 6. Well, let's not better yet make it pi over 3. No, I'll make it pi over 6. Okay, so let's make this pi over 6. Okay. That denominator will tell you how many, I guess you could say, pi pieces you're going to cut that numerator into. Sections not numerator, I don't know why I said numerator. The top half of the unit circle. Will be divided in 2. Okay, so your denominator is just going to tell you that. Okay, and I picked pi over 6 because it works the same way with pi over 3, pi over 4, all of them. Okay, so you have 1 pi over 6, and I'll put a 1 there. Let's say if you go here, theta equals 2 pi over 6, which ends up being pi over 3. Okay. Let's say if we swing up here, theta equals 3 pi over 6, which remember is just pi over 2. And you know you did it right if by the time you get up here, whatever you start counting with ends up being pi over 2. So you know you did it right. And as you keep going, remember that straight line is just pi, 180 degrees. So if you did everything right, by the time you get here, it should simplify to just be pi. So we have 3 pi over 6 here. So that means the next one will be 4 pi over 6. So theta equals 4 pi over 6. Or you can just make that 2 pi over 3. I'll rewrite that to give it a little more room so it's not cramming everything there. So theta equals 4 pi over 6. It's 2 pi over 3. Bring that down some. Okay, so if we go here, you have 4 pi over 6. So that would be 5 pi over 6. Nope, 5 pi over 6 can't be simplified, so it stays that way. So by the time you get here to 6 pi over 6, it's just pi. Okay. Now we know that this is our 3 pi over 2, because remember you have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi, is a complete circle. Okay, so if we go from 6 pi over 6, let's say we have theta equals 7 pi over 6. Okay, now we have theta equals 8 pi over 6, which is 4 pi over 3. So this would give us theta equals 9 pi over 6, which once we simplify it is our 3 pi over 2. So we have 9 pi over 6. That will give us 10 pi over 6. Which simplifies to 5 pi over 3. Then we have 11 pi over 6. And then when you go one complete circle, 12 pi over 6, which is just 2 pi. So that's a complete circle. So 2 pi is a complete circle. Okay. The reason I showed you that is because what if they wanted you to figure out, okay, what's the terminal point of cosine of 5 pi over 6? You wouldn't want to have to remember a cosine of 5 pi over 6 and know that if you fill out that entire bracket and everything else and all of that. That's too much to try and figure out. So what we're going to do is we're going to use reference angles to where as long as you know the points in quadrant 1, you know the points to all of them. So that's where the reference angles come in. So that's why you don't have to remember all of those, because that will be just a lot to have to remember. Even writing it out, it will be a lot. So this way with the reference angles, you don't have to. Okay, so we use reference angles to find the values of cosine of theta and sine of theta outside of quadrant 1.